So we are starting the flushing process for the FCU. We are in RB4 heat exchanger room to witness the flow in the primary and secondary. The primary flow is 218 GPM and 212 GPM. Temperature primary and secondary flow is like this: 10.317, 6.940. Building side is here. DCP side is here. You'll be checking the VFD frequencies from the building pump. We are in RB4 roof chilled water pump room. We have to check the frequency of primary side chilled water pump. Pump number 2 is running at a frequency of 14.9 Hertz. We are in flat number 103. We're checking the initial BT meter readings before starting the flushing. The FCU has been put on position. The primary temperature is noted as 25.42. There are some issues there, and that's because the flow has just started. That's why. The secondary temperature T2 is noted as 25.53. Okay, that is 0.11. It clearly states that is no heat transfer properly happening, and it's noted as 0. So it means that the flow is not reaching the fan coil unit. We'll check that what is stopping the flow. So previously the isolating valve near the FCU was kept off since it is a guest apartment. So we have switched on the valves, and the current flow is noted as 184 liter per hour, and T1 is now reducing it to 14.42 and T1 to 25. It will again reduce because it's just opened the valve. We'll start the flushing now. We'll start removing the FCUs and clean the parameters. 103, we are checking the grill temperature and the thermostat set points. Temperature is set at 20 degrees centigrade and it has reached 25. FCU has been shut now, the cool mode. We are checking the grill temperature. See the what is the grill temperature now. We are checking the grill temperature to see that how much is reaching. How much is the grill temperature?
21.2.
21.2. We'll see the measurement. Come on. The grill temperature is 19.1 degrees centigrade. Slight difference because it's just missing. It is in the range of 80 to 90. Reading of the coiled air. Common area strainer is being cleaned. There was some debris on that one. Now it is perfectly clean. Clean it some more on the corner also. वो corner पे भी clean करना है. बराबर clean करो. Okay, it's been cleaned. Now it's almost clean. Now we are reinstating that strainer. Back to the common area. 03 FCU has been removed to do a detailed flushing. This is the status of the FCU from outside. We will be proceeding for water flushing of the unit. We are removing the air filter. There is dust inside. We have to clean it. We'll wash it and reinstate back. We are cleaning the air filter. It doesn't seem so clogged, but for the sake of keeping it extra clean, we are cleaning it with a jet hose and there is a bit of debris, but not much. There is dust there, you can see that. Now it's being cleaned. All the FCUs are installed with a washable type air filter, so we can remove and clean this. Yeah, this side we have a bit of dust there. Any dust accumulated in this air filter will stop the airflow, and hence it will stop the heat transfer from the coil. A perfect cleaned air filter is required for ambient air quality as well as proper heat transfer from the seal. We are removing the top panel to see the status of the coil from outside. There is no much of a debris observed on the surface of the coil. Still, we are doing a surface cleaning with soap chemical. Cleaning chemical Culligan Clean Guard 70 F02 is being added for the flushing. The pressure is 0 bar. The pump is being turned on. The VFD is being increased.
CSI 0.
The delta P is 0 psi. Okay, we are increasing the VFD. It's 2 psi.
3 psi.
Working pressure is 0.2 bar. The pressure has been increased to 20 psi. Delta P is 5 psi. 5 psi, and pressure is 0.4 bar. Pressure is increased to 1 bar. So fine, let it run like this pressure because we have 15 psi. Working pressure 1.2. Now the dust has been removed and the pressure has been reached to 10 psi. Now we will continue circulation. Let's see that we can reduce it to 0.8 to 0.7 psi. Now, as there was a dust there at 40 hertz, at 30 hertz it's a 2 bar, and now the pressure has been reduced to 0.8 bar. It indicates that there was some debris inside the coil. It has been removed because of the pressure, and pressure has reduced to 0.8 bar at 40 hertz, and DPT sensor is indicating an delta TP of 10 psi. Circulation is ongoing. The water quality is somewhat okay. It seems clean, but let's see that we can remove much more debris from that. We are continuing the circulation. Time being, we'll start the removal of fan so that we can clean the coil outside. Again, it has been reduced to 8 psi. If it reaches 7.6 psi, the 0.5 psi can be 0.5 bar can be achieved. Now it seems almost clean. We further increase the pressure frequency to 45 and see that can we achieve increase in pressure. Yes, we have increased almost to 0.9 bar, and the pressure has increased to 11 psi. Let's see that we can get any further debris from that. Doing flushing once again with a direct connection, discharge to supply and suction to the tank. We are starting the VFD. The pressure is being increased to 20 hertz. The system pressure has been noted as 0.2 bar. You're having a 0 psi. Please increase the pressure, increase the frequency. The frequency is being increased to 30 hertz. Okay, it has been increased to 30 hertz. We are getting a pressure of 0.4 bar with an open circuit. We have 0 psi, very good. Now it has been increased to 40 psi. The frequency is now 40 hertz. Now the system pressure is 0.8 bar and 0 psi again. Now it has been increased to 50 hertz with a 1 bar pressure, and it's 0 psi. All the debris has been removed from the system. Good. We will remove and reconnect to confirm that psi 0 bar is correct. Now the pump has been connected from the discharge connector to supply with a pressure of 0.2 bar in the system, near to 0.2 bar, and we have a 0 psi here. The frequency is being increased to 20 hertz. The system pressure has been increased to 0.4 bar. Still we have a 0 psi. Fine. It's been increased to 30 hertz. System pressure is near to 0.8 bar, and it's still again 0 psi. Good. Now increased to 40 hertz. 40 hertz. Okay. The pressure has been reached to 1 bar. So we have a differential pressure of 0 psi. After continuous flushing, it has reached, the delta P has reached 5 psi with a frequency of 50 hertz. Supply pressure has been reached 1 bar, 4 psi. Okay, good. Okay, the pressure is reaching 1.4 bars. The inlet pressure is 1.4 bars at 50 hertz. Pressure has been reduced, and the desired pressure is at 5 psi. Pump is still running at 50 hertz. This looks really good. The water quality seems clear. Yeah, we are restarting the process of supply to supply and return to suction because the DPT sensor was connected wrongly. Now it is at 10 frequency at less than 0.2 bar with a differential pressure of 0.1 psi. Now it's being increased to 20 frequency. 20. It's at 20 hertz with a pressure of near to 0.4 bar with a differential pressure of 3 psi. Again, it's been increased to 30 hertz. The pressure has been reached to near to 0.8 bar. We have a 7 psi differential pressure. Now the frequency is again being increased. It's reaching 40 hertz. It is having 1 bar pressure. We have 12 psi. Let it run for some time with 40 hertz. Let it run for some time 40 hertz because I can see a differential pressure. The water quality seems much clear. The pressure has increased to 1.1 bar itself, which was because of the pipe is getting bent. That's pressure is being increased. Come on, let's increase the pressure. Let's see how it goes. So the frequency has been put to the maximum of 50 hertz. Now we are having a pressure of 1.5 bars, and the pressure psi has been reached to 18 psi. Let it run for some time. The pressure is reaching around 1.2 8 bar from the supply line and 18 psi, 19 psi. Now we are starting to clean the coil surface and the air filter to have a proper heat transfer through the coil. So this is our chemical. It's AC Bright, which is basically a soap based coil cleaning heavy duty coil cleaner. It's a heavy duty cleaner which is used for the coil cleaning. That's been added to it. We are putting a cleaning chemical. It's basically a soap based chemical to clean the dust from the surface. The system has been flushed and we are checking the flow again after connecting the CU in flat number 103. Set temperature is 20 and 23.5 and the flushing is successfully completed.